Hi and welcome to this channel and this video. And in this video, I want us to discuss what we call the finite differences. And we use the finite difference in what we call interpolation. I think we'll do that in the next video. And I will discuss Gregory interpolation, which is a common question in the exam. We have what we call backward, and also we have forward interpolation. And for that matter, we are going to create what we call forward and backward finite differences. Now, to start with, if you have tabulated data, for example, if you have a function of x, say here you have a function of x, not here you have the independent variable first. You have the independent variable x, and you have a function of x, or y is a function of x, or whichever you want to call it. So you can say y is a function of x. If you have the first value here on the table, we call it x naught, and the first value here, we call it y naught. Here you have x1, where x1 is the first value of x naught plus a certain interval h, and the functional value here will be 1, y1. Of course, y1 is a function of x1, and so on. The next value here will be x2, which is equal to the first value of x0 plus some interval 2h. And the functional value here is y2, which is a function of x2, and so on, up to the very last value in the table, which we can say is the last value here is xn, which is x0 plus nh, and the functional value here is yn, which of course is a function of xn, and so on. Now, these values of x, we call the value of x the argument. The value of x, or the independent variable x, is called the argument, and the dependent variable y is called the entry. Well, remember, y is a function of x. Y is a function of x. So these are tabulated data. Using this tabulated data, we can create what we call finite differences. And two types of differences exist. Two types of finite differences. Okay, actually there are not two. It's only that I want us to discuss only two. You have what we call the forward differences. Forward differences. We have the backward differences. We even have another type of differences, like central differences, that we are not going to discuss. Remember, the video are only geared toward the exam, so that you can pass the mathematical exams with differences with this effort. That doesn't mean you should not work hard, but it means you need to save time for other subjects. That's why I try to make the videos to be very focused to the exam. But of course, you need to expand more beyond what I'm trying to give you. The forward differences are represented by this symbol. This is the symbol for forward differences, and this is the symbol that we use for backward differences. Now here, let's something about the forward differences. Forward, we call them finite differences, so forward finite differences, but you don't have to keep on using that word. Finite differences. Suppose we take this value of y1, we subtract the very first value in the table, which is y0. This will give us the first difference of y0. If we take y2 minus y1, this will give us the first forward difference of y1. we take y3 minus y2, this will give us the first forward difference of y2, and so on. If we take yn minus yn minus 1, this will give us the first forward difference of yn minus 1. All these, they are called fast forward differences. From the fast forward differences, we can also create a table of backward differences. I mean, we can also come up with backward differences. For example, suppose we take the fast forward difference of y1 minus the fast forward difference of y0, it will give us the second forward difference. The second forward difference of y0. If we take the fast forward difference of y2 minus the fast forward difference of y1, it will give us the second forward difference of y1. And again, if we take the second forward difference of y1 minus the second forward difference of y0, it will give us the third forward difference of y0. You use the previous differences to get the other differences. It's also possible to express any of these differences in terms of the functional values or in terms of the entry. For example, let me remove this. If we take that second forward difference of y0, we can also express it as this is the forward difference or fast forward difference of y0, which will be equal to forward difference of fast forward difference of y0 is y1 minus y0, which now becomes fast forward difference of y1 minus fast forward difference of y0, which now becomes the fast forward difference of y1 is y2 minus y1 minus this one y1 minus y0. We now become y2 minus 2y1 plus y0, and so on. Though this will not be very relevant to our lesson, you can go and expand further using the functional values, that is y1, y2, y0, and so on. Now, from this knowledge, from whatever you have discussed, I want us to create a finite difference table. We are going to start with forward difference table. Forward difference table. Actually, these are finite difference table, but it's for forward. Sometimes you can be told to create a finite difference table. So they may mean the forward difference table or the backward difference table. Let us start with the values of the argument here, x. Here you have the value of argument. Here we have the value of entry. Here we have the first forward difference, second forward difference, third forward difference, fourth forward difference, fifth forward difference. The first value of the end argument is x0, x1, x2, x3, x4, x5. The value of the entry or the functional value is y0, y1, y2, y3, y4, y5. We take y1 minus y0, first forward difference of y0. y2 minus y1 is the first forward difference of y1. y1 minus y0, this is the second forward difference of y0. y3 minus y2, first forward difference of y2. This first forward difference of y2 minus first forward difference of y1, this is the second forward difference of y1. And then you continue like that. This is this two is first forward difference of y3, or I should have preferably continue with this one. Here I should have said that forward difference of y0, and then these two will give me second forward difference of y2. These two will give us second, third forward difference of y2, not y2 but y1. Third forward difference of y1. This will give us fourth forward difference of y0. These two, y5 minus y4, will give us first forward difference of y4. The first forward difference of y4 minus first forward difference of y3 will give us the second forward difference of y3. These two differences, second forward difference of y3 minus second forward difference of y2, will give us that forward difference of y2. These two, that forward differences will give us a fourth forward difference of y1. And finally, these two fourth forward differences will give us the fifth forward difference of y0. So this is a finite difference table, and it is for forward differences. In interpolation, you'll be required to find some unknown value of the entry for a given argument. And in that case, if you are required to use Newton-Gregory forward difference interpolation formula, or if you are simply told to use Newton-Gregory forward interpolation, you'll be using these values. These are for forward difference interpolation. For example, for a certain value of x somewhere here, you may be required to find the unknown value of the entry y. In that case, you can use Newton-Gregory forward interpolation formula. Maybe you are given a certain value of the argument, and you are required to find unknown value of the entry. Okay, in this case, you have a choice. You can decide to use these values here, they are for forward difference also, or you can decide to use this value here at the top. It will depend on your choice. Mostly, I prefer using the values at the top, but I will show you how you can either use this value here or this value here, depending on what you want. But both of them will give you the same answer, depending on the position of the unknown value of the entry that you are required to find. But simply what I want us to agree, this value, use them for forward difference interpolation. But also I have to mention that for a question where you are required to use Newton-Gregory for backward interpolation, you use these values here. So this table we have created here can be used for a question where you'll be required to use forward interpolation if you use these values here, or if you use these values down here, they will be used for backward interpolation. But we're also going to create a backward difference table so that we can see what we need. So let's remove this and discuss about backward interpolation. Now we also have what we call backward differences. Backward differences. Suppose we take y1 minus y0. This one we can call it the first backward difference of y1. Suppose we take y2 minus y1. This is first backward difference of y2. Suppose we take y3 minus y2. This is fast backward difference of y3, and so on. These differences, we also refer to them as fast backward differences. They are called the fast backward differences. But now suppose we take the fast backward differences. We take the fast backward difference of y1 minus, not y1 but y2, minus this one, fast backward difference of y1. This will be second backward difference of y2. Suppose also we took the fast backward difference of y3 minus the fast backward difference of y2. This will be the second backward difference of y3. So these are called second backward differences. Second backward differences. Similarly, we can use the second backward differences to create third backward differences. For example, second backward difference of y2, not y2 but y3, minus second backward difference of y2. This will give us the third backward difference of y3, and so on. So these are third backward differences. That's how we create backward differences table. Similarly, as we did the other one previously, for example, you can also express any of this in terms of functional notation. That is, for example, the second backward difference of y2, we can say this is backward difference of first backward difference of y2, which is equal to backward difference of y2 is y2 minus y1, y2 minus y1, which now becomes backward difference of y2 minus backward difference of y1. Backward difference of y2 is expressed as y2 minus y1 minus this one. Backward difference of y1 is y1 minus y0. It now becomes y2 minus 2y1 minus, not minus but plus y minus plus y0. So that's how we express the second backward difference table in terms of the functional value y. But now, how can we create a finite difference table from this? Let us create a finite difference table for backward differences. The value of the argument, x. Remember I said the values of x, they are called the argument. The entry, the first backward difference, second backward difference, third backward difference, fourth backward difference, fifth backward difference. And the first value here is x0, x1, x2, x3, x4, and x5. And remember what we said, x0, x1 is the first value plus certain interval h, x2 is the first value plus 2 intervals 2h, x3 is equal to the first value x0 plus 3 intervals 3h. So they have similar differences between them. You must have similar differences between them. Take this value here, y0, y1, y2, y3, y4, y5. So that y1 minus y0 is first backward difference of y1, somewhere in the middle, first backward difference of y1, y2 minus y1, first backward difference of y2, first backward difference of y2 minus first backward difference of y1, This is second backward difference of y2. y3 minus y2. First backward difference of y3. First backward difference of y3 minus first backward difference of y2. This is second backward difference of y3. Second backward difference of y3 minus second backward difference of y2. This is third backward difference of y3. y4 minus y3 is first backward difference of y4. These two backward differences will give us second backward difference of y4. These two backward differences will give us third backward difference of y4. And these two third backward differences will give us fourth backward difference of y4. y5 minus y4 will give us first backward difference of y5. First backward difference of y5 minus first backward difference of y4 will give us second backward difference of y5. Second backward difference of y5 minus second backward difference of y4 will give us third backward difference of y5. Third backward difference of y5 minus third backward difference of y4 will give us fourth backward difference of y5. And fourth backward difference of y5 minus fourth backward difference of y4 will give us fifth backward difference of y5. If you follow the previous table that we created, here y0 was persistent, like we had y0, 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 up to the last one, forward backward difference. For forward differences. But now for backward differences, y5 is persistent. y5 is persistent. But the same table, if you took these values here, you can use them to answer a question for forward interpolation. And these values here, you can use them to answer a question for backward interpolation, where you are dealing with backward interpolation formula, like Newton-Gregory backward interpolation. So how you create the table is the same. That's what I mean in short. How you create the table is the same. Now the difference is, depending on which formula, if you're using formula for forward difference interpolation, then you are going to use these values. If you're using a formula for backward difference interpolation, you are going to use this value here.